Morning once again to all of you.
Good morning, ma'am.
A bit of this was done yesterday. We are going to do the detailing of how the action reactions taking place in the horse cart. Please start with.
Yes, ma'am. Why don't you educate the horse properly? Weight of cart
WC.
W WC is balanced by reaction RC on the cart offered by the ground. Forward pull of the horse on the cart THC is balanced by reaction pull of the cart on the horse TCH.
So it is the
If
cart
the
and the horse. Got it? So
yes,
C
ma'am.
is the cart and H is the horse.
If the horse pushes the ground in a slanting manner action, the reaction offering by the ground is resolved into vertical and horizontal components. The
Yes, tell
vertical
me.
the vertical component V balances the weight of the horse WH. If the horizontal component H is greater than friction F, then the horse cart system will move forward with acceleration.
We will not go much in detail about this. It's just the thing that how the cart moves, how the horse cart moves, how it is balanced, and how the horse is overcoming the frictional force and then only it can move forward. You agree with me? So there's a friction between the horse hoof and the ground, the horse cart and the ground. The force of the horse and the cart should be more than the friction. Then and then only the cart will move. Do you follow me? Hello? Do you follow me? See the friction over here with the ground
Yes, sir.
and the friction over here with the ground should be less than the force applied by the horse and applied by the man on the horse. Then and then only the cart will move forward. You agree with me? Hello? Can you hear me?
Yes, ma'am.
Yeah. Did you understand what I said just now? There are two forces applied. One force is by the horse, by the man on the horse. It's clear? The other force, the opposing force, which is the frictional force. This one, F you can see, which is opposing, is going back. So this force has to be less than the force applied by the horse and the man on the horse. Then and then only the cart will move forward. Otherwise, the cart cannot move. Is it clear or not?
Yes.
All of you understood? Said Heather? Hello? Yes?
Yes, ma'am.
So, action you can see the hoof on the ground, that is action, and the ground is giving the reaction to the horse. Got it? In this case, this is the weight of the cart. Can you see this? This is the weight of the cart. Yes? And this is the reaction which is going up. It's a reaction. So, weight of the cart is the action, and the man on the top who is moving the cart is the reaction. Now we see one more activity of action reaction, the recoil of a test tube activity. So what you are doing here, the test tube has got water and is being heated up. So you can see it's getting heated. There's water inside the test tube and the cork, there's a cork over here. Can you see this? This is a cork. Afterwards, what happens, we'll see. Yes, please read.
Yes, ma'am. Here, the event of popping of the cork is considered as collision. Total momentum before collision is zero. Total momentum after collision also must be zero. Hence, the velocities of the test tube and the cork are adjusting themselves. That is, the cork and the tube fly away in opposite direction. Also note that velocity of the cork lighter is faster than that of the test tube heater.
Heavier, heavier, heavier. This is what we have learned that momentum has to be equal before collision and after collision, right? So whenever you're heating the test tube, obviously what is happening over here? The water is changing to gas. Am I right? Hello? When you are heating the water, what happens? The water over here is changing to gas, water vapor. Is it right? Say something better. Hello?
Yes, ma'am.
Yeah, can you hear me?
Yeah, ma'am.
So when we are heating the water, what is happening? The water on the surface is getting transformed into water vapor. Do you agree with me? Hello? So what happens? Here it is developing up energy. It is developing energy. And when the lid cannot control this energy, it flies off. As it flies off, what happens? The test tube goes back. It's like the gun activity, remember? Excuse me. The bullet goes ahead and the revolver goes back. The same action is observed here. The lid flies off in this direction, that is the right hand side, and the test tube goes backward, that is left hand side direction. Now they have balanced it. This reaction is balanced because we know that action is always equal to reaction, but opposite in direction. Remember? Remember? Boys, do you follow me? Hello? Hello?
Yes, ma'am.
Yeah, did you understand?
Yeah, ma'am.
So, these forces sorry, popping up of the cork like this. See, the cork is gone out, has come out of the test tube with a force, and the test tube is going back. So, these two forces, F1 and F2, they have balanced. So momentum is balanced before the activity and after the activity. It is balanced. Now we'll see conservation of momentum. What is momentum? Mass into velocity. Before an activity and after the activity, the momentum remains the same. This is what we have to see. Let's start.
Conservation of momentum. The law of conservation of momentum states that.
Conservation. Low, Sahim.
Yeah,
It is
yeah.
conservation, not conversation.
Sorry,
It
ma'am.
is conservation. Is thank you.
Conservation. Sorry. The conservation of momentum. The law of conservation of momentum states that the sum of momenta of the two objects before collision is equal to the sum of momenta after the collision, provided there is no unbalanced forces acting on them.
So we always take for granted that this is balanced force, but actually it's not so. In day-to-day life, we always get unbalanced forces. Yes or no? In day-to-day life, we generally come
Yes, ma'am.
across unbalanced forces. Balanced forces are very rare. Got it? Balanced
Yes,
forces are very rare. So, but for any hypothesis, we have to take certain generalization. So, we will talk about that everything is happening when there is a balanced force. Is it clear?
yes, ma'am.
Okay.
This means that the total momentum of the two objects is unchanged or conserved by collision. If two balls A and B of masses MA and MB are traveling in a straight line with initial velocities UA and UB, and if UA is bigger than UB, the two balls will collide with each other during collision at
Now
a
stop.
time.
Same now stop. We'll do this line and explain. Okay. You can see two balls. This one is A and this one is B. You can see these two balls? Yes? At least say answer me, Peter. Can you see those two balls A and B? Hello? With masses MA and MB. Yes? They are traveling in a straight line. Can you see this arrow? They are traveling in a straight line. Now, what is the velocity? UA of A and UB of B. And what we consider? That UA, the velocity of A, is more than the velocity of B. So what will happen? Obviously, A will collide. You can see this collision. A will collide with B. Did you understand this much of activity? Hello? The
Yes,
instant.
ma'am.
No?
Yes.
Did you understand this much of activity? Now we will start, okay? See, we will go step by step so that you understand what has been depicted. Yes. Now say.
During collision at a time t, ball A exerts a force FAB on the ball B, and the ball B exerts a force FBA on ball A. If VA and VB are the velocities of ball A and B after collision, the momenta
That's it.
of ball
That's it. That's the same.
of
Step by step we will go. So you will understand. Now there's a collision. You agree there's a collision over here. This is the collision. Yes, A is colliding with B, right? At particular time t. So obviously ball A, this ball A is exerting a force. Which force? FAB. Which force it is exerting? A on B. So what it will be? Force AB. Is it clear? So the direction will be like this. So FAB is a force which is applied by A on B, whereas we have to have reaction also. This is action. FAB is action. So what will be reaction? Ball B on A. So it will be FBA, which the arrow will be showing as a backward direction. You got it now? So action is this one and reaction is backward. Did you understand this activity? So which is action? Force A on B, FAB. What is reaction? B on A, FBA. Understood? Boys, did you understand? Hello? And then this initial velocity will change to final velocity. So UA will convert to VA and UB will convert to VB after collision. This is before collision and this is after collision. Tell me, did you understand?
Yes, ma'am.
Am I audible? Because I have to repeat it so many times and then I get your response.
Yes,
Hello?
ma'am, you are audible.
But then why I don't get your answer promptly? I literally have to ask 3, 4, 5 times, then only I get your answer. That's why I'm asking, am I audible? Why does it take so much of time to get the response? Hello?
Yes, ma'am.
Yeah. Okay, this much have you understood?
Yes, ma'am.
This one is before collision, this is collision, this is after collision. This much have you understood? Now we have to find out the momenta of this and before collision and momenta after collision. You understand now? This is what we are going to find out. Yes, please read. Yes, start reading.
The momenta of ball A before and after collision are MA, MUA, and MAVA. And the
What is momentum?
momenta
What is the actual formula of momentum?
uh,
Yes, P is equal to mv. Remember?
V. Yes,
So mass into velocity. So obviously the mass over here is A ball is ma. Agree? What is the velocity of the ball? ua. So ma into ua. So you got this? Hello?
yes, ma'am.
Yes. So this is the for one ball, that is A ball. So obviously what we are going to do? We have to add the initial velocity before collision and the final velocity. Is it clear? After collision.
Yes, ma'am.
Start.
And the momenta of ball B before and after collision are MBU and
B.
MBUB.
MBUB. You should understand see what is written over here. MBUB and
and MBV.
VBB. Got it now? So the momentum will be here MAUA and over here MAVA. Right? So this is for the A. So you have to add, isn't it? Before collision and after collision. Similarly, MBUB MB and VB. Got it? So these are the momentum of A and B. Because you know that momentum P is equal to mass into velocity. So for any problem in this slide? Hello. Any problem, beta?
No, madam. Change in the momentum of ball A during collision is equal to MAVA minus MAUA.
One question I want to ask you. Change we did. Whenever we find a difference, which number should we take as the first one? Can you tell me? Now we took MAVA, why not MAUA? Can anyone tell me? How do you find out the difference generally? The small number is generally or the final minus initial. That's how we do, isn't it? Hello. Hello, can you hear me?
Yes,
Boys, can
ma'am.
you hear me? Yeah. So this is final F and this is initial I, right? So V is the final velocity and U is the initial velocity. So obviously the difference has to be from final, isn't it? Because initial started from here, then it came here, isn't it? So obviously difference will be from here to here. Yes or no? So I have to minus final minus initial. What do you say? Or should I minus this is A and this is B, for example? What do? I do B minus A or I do A minus B. Which one is correct? This is initial, remember, and this is final. What do I do? Initial minus final or final minus initial? Do you understand what I'm asking you? Hello?
Yes, ma'am.
Do you understand what I asked you just now? From where do we find out a difference? From final to initial or from initial to final? That is what I'm asking you. Generally, the difference is from the final to initial, right? So, VA is the final velocity, U is the initial velocity, and MA remains the same. M is common, it's not changing. So, you can see over here, MA and MA is common, it remains the same. So, what is changing is the velocity. This is the final velocity, and this one is the initial velocity. Did you understand this much? This is the momentum of ball A. Got it? Yes. Now what you have to find out? Rate of change of momentum. So rate of change of momentum of ball A, obviously A is colliding with B. So what will the force? AB. What will be the, whenever we talk about rate, so it has to be divided by T because we are measuring it with time T. So that becomes a rate. So what will the rate be? MA becomes common, we bring it out, and what remains inside? VA minus UA divided by T. This much have you understood of ball A?
Yes, ma'am.
Similarly, I will take up this slide better, okay? Similarly, change in momentum of ball B. A is done. We have finished A. Now we will do with B. What it will be? Same way you have to find it out. The only thing will differ will be the name of the ball. Now, the name of the ball is B. It will be MB BB minus MB UB. What will the rate of change of momentum? Obviously, when A is colliding with B, that is action, the reaction will be force BA. It will be MB, common is MB. You can see over here, MB is common. And then what remains inside the bracket? BB minus UB divided by T. So that is the rate of change of momentum of ball B. This much have you understood? So separately we found the change in momentum and the rate of change in momentum of ball A and B. Any problems so far? This is for ball A and this is for ball B. Any problem? Hello?
Yes, ma'am.
Any problem? Did you understand or do you want me to redo it?
No, ma'am.
Now what happens? We work with Newton's third law of motion. Yes, read now. Now you read. Please read. So according to Newton's third law of motion, the force AB, which was exerted by ball A on ball B, is equal. Remember that. So action is equal to reaction, but it is opposite in direction. So it is opposite to the force B exerted by ball B on ball A. So what we will write? That FAB is equal to FBA. This is what we learned. But it is opposite in direction. So what I will put here? Minus. Do you understand? Do you understand? Yes, ninth standard. Did you understand this? It is equal. FAB is equal to FBA. Its action is equal to action, but it is opposite in direction. So how do I show opposite? By putting a minus sign. Have you understood? Hello? Do you understand or not? Can you hear me? Hello, can you hear me? Yes. So what will the momentum? MA? It will be VA minus UA upon T. And here it will be minus MB, BB minus UB upon T. Yes? Do you understand or not? Here the FAB will be, just a moment, FAB, this will be, this will be FBA, right? Is it clear? Is it clear, boys? So what is FAB? It is MA VA minus UA upon T. Okay? Okay? Now we will elaborate because this T and this T gets cancelled. Is it clear? So it will become MA VA minus MA and UA. This is what you get over here. I'll do it again to make it clear to you. Don't take this one. It has to be MA here, not away from equal to. It should be on the right hand side of equal to. This T and this T gets cancelled. So if you multiply, what it becomes, see, MA VA minus MA UA. Okay, this is what we have done. We have solved. Now we have to solve this. Is equal to minus. You can see the sign, minus sign. MB VB, and then this is in bracket. So I will put minus only. MB UB, right? And when I open the bracket, what it will become? MB VB plus, because minus this minus becomes plus. MB UB. Got it? This is what you have got now. Now you have to solve the whole reaction, sorry, equation. What will we do? We will put A together on one side and B on the other side. So what happens? We'll see again. First you will take this one and this one. Now, as we know that this minus is in the beginning, so again we'll put this one in the beginning because it has got the minus sign. So what we will do? Minus MA UA, right? And you can see over here, what is written over here? MB UB is equal to MAVA plus MBVB. So what is written over here? That momentum of the two balls before collision is equal to the momentum of the two balls after collision. It remains the same. Got it? Hello? But this also you can understand law of conservation of momentum, that when two or more bodies act upon one another, So what are the two bodies which are acting upon one another? One is striker and the other one is the coin. Their total momentum remains constant. There should not be any other external force except the striker hitting the coin. So the striker before the collision and the striker after the collision has to be same. The momentum has to be same. You see a big car and a small car over here. Now, please, one of you start reading. Suppose there's a big and a small car which is moving in the same direction, but they have different velocities. Now, the bigger car mass is m1, initial velocity is u1, and the smaller car mass is m2, and initial velocity is u2. But we know that the bigger car, such that, yeah, bigger car has got more velocity than the smaller car. So the velocity of the small car is less than the bigger car, that is u1. u2 is less than u1. Now for some time, these two cars collide. That means the bigger car is pushing the smaller car for short time, that is t. So obviously, due to the collision, the velocities of the cars will change. So after the collision, let the velocities be v1 and v2. v1 for the bigger car and v2 for the smaller car. Now, during collision, we are thinking that the bigger car is giving a force, is exerting a force F1 on the smaller car, that is action. And in return, the smaller car is also exerting a force F2 on the bigger one, that is reaction. When force F1 is acting on the smaller car, obviously the velocity will change from u2 to v2. So we know that force is equal to ma. Remember, force is equal to ma. This is what we had learned earlier. So now we are talking about force F1. So it becomes, see, the F1 is acting on the smaller car. So force F1 is from the bigger car to the smaller car, that is m2a2. Got it? So F1 is acting on m2a2. So what I will get? F1 is equal to m2, and what is acceleration? Change in velocity. So it is v2 minus u2 upon t. Same way, we talk about the reaction by the smaller car to the bigger car. It will be F2, but it is applied on the bigger car. The bigger car mass is m1, and what is acceleration? a1. So it is m1 into v1 minus u1 upon t1. And we know that the Newton's third law predicts or depicts that F1 is equal to minus F2. They are equal. F1 is equal to F2 equal. But it is in opposite direction, so it has to be with minus sign. What do you find? You just equate both of them. We find that m2 into v2 minus u2 upon t is equal to minus m1 into v1 minus u1 upon t. We know that we can cross this t, what it will become? M into v2 minus u2 is equal to m1 into v minus u1. So it becomes m2 v2 minus m2 u2 is equal to m1 v1 minus, what it will be better? Minus m1 u1. Okay. So you just take the minus sign over here and make all the things as plus. You reshuffle, you get m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. And here you can find that the initial momentum of the bigger car is m1 u1 and the initial momentum of the smaller car is m2 u2 is equal to the final momentum of the bigger car and the smaller car after collision. So what you find? That the total momentum before collision is equal to total momentum after collision. This is what is the law of conservation of momentum. Have you understood? Boys, have you understood? That's why I took it up, because It was all sorts of equations, and if I take it up, it would be easy for you to understand. Have you understood this solving of law of conservation of momentum? Boys,
Yes.
you have to do all these equations, solving of equations in your rough book without fail.
Okay.
Yes, all of you, because this is very important. Numericals are based on all this equation. If you don't understand, then you won't be able to solve the numericals. Okay, so before going to sleep, please go through the uploaded video, understand, and if you don't, call me up. Okay,